So today we have a hard problem. I saw that the daily challenge was hard and it looked, I already solved meeting rooms too, so why not give it a try. It was just a sweep, so we are given a... Okay, they finally added the explanation here, great. Each meeting will take place... What the hell? That held the most meetings. Each meeting in an unused room with the lowest number. The delayed meeting should have the same duration as the original. Oh my. When a room becomes unused and meetings that have an earlier original. Okay. Return the number of rooms that held the most meetings. If there are multiple, return. So you want to tell me 0. Number of the... Oh my days, bro. What? There's up to 100 meetings only. I mean, you could just do this with a priority queue, right? Since and technically you could go through time, because if starts and ends are unique, and there is, second of all, there is just 100 of them, so if they all overlap, that's 10 to 7, so well, you wanna so a meeting comes until a room becomes free. Delayed meeting should have the same duration. Okay, so we can calculate how many rooms are necessary at each point. Or maybe not. And how do you know how many amount of rooms you need? Oh, and is the number of rooms we got. Okay. Oh, so there is 10 to 5 meetings. Okay. So, I mean, we sort by start. Are they sorted by start? No. And then we try to put them in a room. I mean, that should not be too difficult, bro. That should not be too difficult. Like, we go and we find is room free. You pick the first free room. Okay, well, we need to, so let's say we are at some interval and we want to know, is there a free room? And we are like, there isn't one. What are we gonna do? Well, the rooms will be free at the time well, we need to go through the time, so we can have a priority queue with events, and okay, so let's say I have these guys in, I put all three in some room, and then this one comes in, and what I need to store is the time the room will become available, so that's at 5, and the time and what room it is. And now if we get a new interval, we want to put it into the one which ends the soonest, so we just slap it onto there. We slap it on there, and what we do, well, we increase the end by how much it takes, so 5, so 4, 5, 6, 7, 8, so we finish at 10. Yeah, that's fair. And okay, I guess, and that's it. And you just go through, you store which room had how many intervals, and that's it, I guess. So vector int hosted m is meetings, number of meetings, and then we need a priority queue. Priority queue, I'm not sure how, what is its API. So I'm okay, there is no add, so maybe pk push, not my second choice. So is it by default min, or it's max? Okay, I mean vector int I think is enough. Okay, so we got a main queue, but we need pair int pair int, and also here I could just use set. Why am I even doing this, bro? There is nothing great. Okay, let's do it like this. So that's our variable, these are our data structures. And now we go for auto, I should sort, I think so, sort meetings begin meetings end, for auto I mean meetings, and what we do, meetings so we got the int start m0 and int m1, and so we grab the start and end, and then what we want to do, well, int call it the room, should be 0. Now if pq, actually the int room pq size, so that's the room that is available. If room m, then something happens. So that is, we need to edit to the one that finishes the soonest. So auto ends room number is pq top pq pop, and on pq push ends plus e minus s, and room number, and then we want to do hosted room number plus plus. Okay, and then we want to do hosted room plus plus, and then pq push, and then we do end room, I guess, and then int best room if hosted I hosted best room room is equal to m. What is m? Why doesn't it not work? Where is vector in, bro? What are you saying? Oh, what? Wait a minute. Like that. Okay, great. This worked. Let's see if this works. Wrong answer in half the test cases. So we go from 0 to 10. Then we go from 1 to 2. Interesting. Okay, I now know. I mean, there is up to 100 there, so problem is you need to pick all of the available ones, because there could be multiple available ones, and you don't want to pick the one that ends the soonest. You want to pick the one with the smallest number. Are you sure about that? And what unused room? Okay. Meetings that have an earlier original start should be given that room. So what's the problem? Is that if there is a room available, Okay, so the problem is when room is available, then we want to do some shenanigans. Yeah, this is the problem. So I need to have another priority queue. Int vector int unused. So let's iterate for rooms. Unused pushback I. So what we do, well, if there is no unused room, then we get the one which ends the soonest and we push it back so it's not unused. But if it's less, available, let's call it used. But otherwise, if less are used, this should not really, bruh. We need to remove the ones that okay, so while not pq empty and pq top first is more than or equal to start, then auto room number. Okay, so we pop that, and now unused push room number. So we pop them and we get this. If all are full, well, you have to add it to the one that becomes free at some point. Otherwise, if there is less of them, then we want to get this the first one. So int room unused top unused op. So that's our room, and we remove it from there. I mean, I guess this works. Not push back, but just push. Okay, this passed. This should pass. Runtime error. What? How could you assign overflow? Are you sure? I guess. Okay. Oh my days. Define long. The first one is the time, so I guess it should be LL. That's the number of the room. So meeting, I guess it's long, and then whatever. I guess. Let's run it. There's overflow in that many cases. Let's see. Okay. Probably not the most efficient solution, but m log m plus m times n, counting using priority queue. Used rooms, unused rooms. Yeah, that's what I did. Okay. So let's do a solution out of my solution and let's go eat. Because I couldn't eat before this. Pretty sweep. I don't know what I'm doing. Oh my days. Let's keep track of used rooms ordered by the one ordered by their availability time ascending and the track of available rooms ordered by their number ascending, since we have to pick the one with the lowest number. Approach. At first we sort the meetings by their start points. Then, before processing them, all rooms are available, so we put them in the unused priority queue. Then, as we process meetings, we first remove all we also keep a used priority queue with pairs available at room number pairs. It should be used min priority queue and unused min priority queue. Then, as we process the meetings, we first move all used rooms that become available, process meetings before the current meeting starts. To the unused priority queue, min priority queue. And then if no rooms are available, we pick the one that starts that the one that becomes available the soonest. In case of ties, we pick the one with smallest number. This is handled by the priority queue, and we add it back into the list. We increase the count of tasks done in it and add it back in edit back into used with new available at increased by the length count. We increase the count of meetings done in it and edit back into used with new available at increased with available at increased by the length of the current meeting. Some rooms are available. We take one from the unused min priority queue and put it into used with appropriate available at. Okay, time complexity. Well, this is space complexity is O of m, since we store at most all of n actually, since we store at most n rooms in both priority queues combined at each time complexity. Well, we have to first sort the meetings and we first sort the meetings in O m where n is the number of the meetings, and then, well, okay, this is m log n, but what's up with this? We do this once a while, so if I pop all of them and then push all of them, that's gonna cancel out. So because if I pop all this, then I'm not gonna do it for another n operations. So I think this is not gonna happen in each iteration. Then we pop and push a meeting a room for each meeting which has a time complexity of m log n, since in each priority queue there will be, since we store rooms in the priority queues and there will be at most n of them in each one at all times. What about the removal of the unused rooms for each meeting? I mean, if we pop the unused rooms and then you use one of them and then if you use one of them, because if you okay, then you are gonna use at most one of them, so you can pop one of them. So suppose all rooms become available before a meeting starts. When are all gonna become available again? That is, when will we have to do O n log n of work again? Maybe I should do it like this. I don't know. That's weird. Only after we push all n rooms back to used, which will be only done after processing and meetings, so we do all of n log n work every n meetings. So this only is us meaning we do all of log n work per meeting amortized, giving us the final time complexity of O m log m plus m log n, and then there is some m log m, and then that's it, because in this it's already hidden that we do log n amortized for this and then log n here. So okay, something like this, who cares? Priority queue, let's call it like that, why not? Okay, goodbye.